Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're here for the output transformer shootout, which we have lined up here. This is a 2A3 amp with AC heaters. It's the build that I'll link below that I've did with using these Heyboer output transformers, and I did another one with some FC20, kind of an upscale model, and it got me to thinking, let's test some transformers. Main thing that got me was a customer sent me a pair of these little, see, they're H-203S 7 watt 3.5K transformers to use on a 2A3 build. And I was a little concerned that given the higher voltage and the higher wattage we're running these tubes at, that we're getting about 5 watts on the output, which is pushing, saturating this little transformer. And before you can see we haven't drilled the holes for the transformers yet, wanted to test these and make sure that they were going to be satisfactory at least. I don't want to put my name on something that to me doesn't perform well. And so that led me to thinking, hey, let's just run some wires out of the back and, get the voltages all settled, make sure everything's ready as far as that goes, and then make it so that I can swap different output transformers into one channel, and then run the analog discovery 2 and look at the frequency response and the distortion, that kind of stuff, versus frequency and the power versus THD thing, and just see how these different transformers perform. And so I got a whole little lineup here of 3.5K SE transformers. And let's go over what we're going to be testing. And we'll start with the cheapest one, which is this little Edcore 15 watt 3.5K. This is the transformer I use on my EL34 builds in a 5K version. It's a pretty nice sounding little transformer, and it comes in at $100 a piece. And this is all without shipping, and just kind of estimates looking at, either retailer or what they're going for on eBay. So, $100, you get these little guys. So next is this musical power supply. Matt wound these up for me to try on my budget 300B build, or my standard 300B build. I kind of remember to call it that. Okay, standard 300B build. It's a 3.5K 20 watt output transformer, and we're going to hook it up with this 2A3 and see how it performs versus these other ones. So next in the price lineup is this little Hashimoto. Well, actually, the next in the price lineup is this Heyboer. It's a 3.2K 20 watt, and you can see it's pretty massive little beast here for what it sells for. $150 a piece if you buy 2 of them. So next is this Hashimoto H203S. Comes in at $225. And then right there next to it, almost the same price, is this Hashimoto HC203U, which is a Edcore version of a 3.5 20 watt transformer they sell. So this is 20 watts, this is 7 watts for the same price. So yeah, I'm curious to see how those two perform against each other. I've used these before in my 45 amp that is the 7K version, or the 5K 7K version, or is it 7K 10K? Anyway, I've used that one before. I think it's a 7K 10K. I've used that one before in an amp, and they sounded really good. But it was a very low power amp, and so these were way overkill, not being stressed anywhere near their rating. And so it'll be interesting to see how this transformer performs at a 5 watt level in an SE amp. And those sell for $230, so they're about $5 more, which is, to me, inconsequential. Same price. And then the most expensive one in the shootout is this ISO FC12S. This is what I use as the upgrade transformer in my EL34 amp, which runs at 7 watts, and they perform very well. And I'm expecting them to work really well in this application too. And it's got a multi-tap. You can go 2.5K, 3.5K, 5K. I can't remember whether it'll go what it actually goes up to. It'll go up to 7K. So you can either use it as a 2.5K, a 3.5K, a 5K, or 7K. And we're going to be using it at the 3.5K setting. And so this should be interesting. This transformer is going to stay on this channel just as a load for this tube because I want to have, both tubes powered up, so the power supply is going to be like it's going to be used, and it gets the plate voltage where it's supposed to be. And then on this channel, we've got the 4 wires coming out, 2 speaker and 2, one goes to the plate, one goes to the B+, and then it hooks up to these jacks, so I can just hook up the analog Discovery 2 and my dummy loads to these jacks and put my input here. This amp has been set up with 2 sets of inputs with a rocker switch on the side, which is kind of I don't like doing them, but when customers really want 2 inputs, I can do it. It's just a lot of work. Anyway, it's all done, ready to go. And I'm really excited to see how these guys perform. Anyway, let's get busy testing output transformers. Okay, so we're starting off with the Heyboer 3.2K 20 watt transformers as our baseline. These are the ones that I built the first 2A3 with. I know these sound really good, and I thought they'd be a good way of looking at the baseline kind of experience you're going to get from this amp. I also rolled around some different tubes, got some RCA red base 5691s, which are the mil spec equivalent of a 6SL7, and the Horizon 2A3 tubes. And the EMLs had just a slight bit more distortion right here at 4 watts. Instead of this 1.18, they were 1.3. So, very similar. Not enough distortion difference you're going to hear, but I did want to have the lowest distortion tubes. The driver tubes seem to contribute more to the distortion than the output tubes. So, anyway, I think we got some really good numbers here. Again, we're under 1.2% distortion at 4 watts. 4.5 watts, which is where we're going to focus, we've got under 1.4% distortion. And, right here, we're probably starting to get into a little bit of clipping at 5 watts. So, really good performing 2A3 amp. So again, this is the THD versus power. Okay? So then we're going to come over here and look at the frequency response. So here I looked at what's the input voltage at 4.5 watts. Because we want to do all this testing near the max power to really stress the output transformer. And I think that's the point we're going to see the differences in these transformers. So we got 0.84 volts RMS in, gives us 4.5 watts. So we did our frequency response at this same 0.84 volts RMS in. And even at full power, we've got a pretty flat looking frequency response curve. Here at 20K, because like this is, you can see this is basically 0 along in here. At 20K, we're down 1 dB. And on the other end, at 40 hertz, we're down half a dB. At 30, we're down 0.87, so we're less than 1 dB. And then even at 20 hertz, we're down 1.5 dBs. We don't hit the 3 dB down until we're getting, 12, 13 hertz. So we're getting really good frequency response, I feel like, for a single-ended amp with 0 negative feedback. So then we're going to lastly look at the THD versus frequency, which I feel like is another real test of the output transformer. And as you can see here, we're doing it 4.5 watts into 8 ohms. At 20 hertz, we've got over 20% distortion, which is not unusual for an output transformer, a single-ended amp with no negative feedback. More importantly is what do we have at 40 hertz, which is 8.5%. And then at 100 hertz, we're down to 3.5%. And then by the time we get to 500 hertz, we're down at the 1.5% that it carries across the frequency range. So below 500 hertz, it ramps up a little bit, but this is still going to sound good. Again, we're going to look at the second order harmonics, which is there, and most of this distortion down here in the low end is second order. And when we look at the third order harmonics, you can see down here on the bottom end, especially above 40 hertz, it's mostly second order harmonic distortion. So that all looks good. So let me jump over. Oh, let me show you the square wave. This is the square wave, and I'll hit the single again just so you can see this is the actual one of the running amp. This is at 1K at 4.5 watts. And I know some folks have said on forums, you know, it's stupid to run a square wave test at max power, but we're testing the output for transformer at max power, so I want to see what it's going to do. And here is the 10K square wave, which isn't doing anything crazy. It's rolled off on here on the front, which we saw in the frequency response curve, and it's not doing any kind of weird gymnastics here in the middle or ringing or doing anything crazy. So to me, this is really good performance at max power, dumping a square wave into this thing. And just so I can show you too that at this point, here's the sine wave. It's not clipping. It's just starting to roll off this bottom a little bit, but we don't have any what I would call hard clipping. So it's cleanly 4.5 watts. So time to pause, go swap in another output transformer, and run another sweep. Okay, so the first contender is also the least expensive. It's the little Edcore 3.5K 15 watt, the ones with the end bells. The open frame ones are terrible. Don't even think about using those. They're guitar amp only. They roll off just starting at about 200 hertz. They're not usable for hi-fi. But the little, what do they call these things? The GXXC, like Gary Xavier SE, are really good little transformers for the money. But you can see we are losing a little something here at the higher power level. It's got really low distortion. It's actually lower distortion by probably 0.25% down in this little area here. So if you're not using these higher power levels, especially if you got like some super efficient clip speakers or something, they might work really well. But you can see right here at 4 watts, while they're down about 0.5%, the line just goes straight up. And by 4.5 watts, you're approaching 2% distortion. So the issue we're going to run into here is this amp doesn't quite make 4.5 watts before it starts clipping, and that's why you're seeing this line like this, you know, the distortion climbing. Really at like 0.85 in is where it starts clipping, which is 4.3 watts. So I'm going to give it a little bit of a break here because I don't think it's fair to test it during clipping. But just understand you're giving up a little bit of power with this transformer. And definitely has more low frequency roll off. The down 3 dB point is closer to 20 hertz. And at 20 hertz it is down 2.65 dBs. But if you got speakers that only go down to 40 hertz, like a lot of them do, it's only down 0.6 dB. So probably still usable. And about the same roll off on the top end. It's flat across here. So as far as the frequency response, it's not going to have the low end bass that the Heyboer is going to have. But again, if you're using bookshelf speakers or something and only go down to like 40 hertz, then it's probably not going to be horrible. And then let's look at the scope. And here's the 1K square wave at 0.85 volts RMS. And as you can see, it's got more ringy-dingy on this front end than the Heyboer's did. And when we go to 10K at this high power level, it's definitely got some more ring-ding-ding across here, across the top. Where the Heyboer, rolled off, but then it was just flat. This is definitely a little wonky here, but it's a lower price transformer, so maybe this is where you're getting what you pay for. Here's the other thing that was problematic. I couldn't even get the test to run at 20 hertz. It was over 25% distortion. So I had to start at 25 hertz. We got 20%, and you can see it levels off fairly quickly. So most of the distortion is in this range in here, and then once you get into this, it's pretty clean, especially in this mid-range area. Let's look at the THD. You can see the second order's about the same, and then the third order, it's got more third order harmonic distortion in this bass region than the Heyboer does, which isn't a positive thing. So with this cheaper transformer, you're going to have a little more of the third order harmonic distortion. You're going to have a little wonkier looking scope pattern, and the frequency response is not going to be quite as good down on the bottom end, as well as making a little less power. I mean, I could real quick, let's see what happens to the scope pattern if we put in like 0.8 volts and see if it's just a factor of overdriving this output transformer for what it can actually deal with. But it's still kind of wonky looking there, so I don't think the lower the power is going to make a huge difference. And it didn't in this graph either. When I lowered this down to 4 watts, it just came down a percent or so on the bottom end. So yeah, that's what you're giving up with this cheaper transformer. So let's take a break and swap in another transformer. Okay, so next on our list is the Musical Power Supply 3.5K 20 watt single-ended output transformer, and it rolls in at $125. So it's $25 more than the Edcore. It does weigh 3.6 pounds versus the Edcore at 2.75 pounds. So it's almost a pound heavier. And when we first look at this THD versus power, we see a very similar curve. The distortion stays super low. It's actually a little lower than the Heyboer, but it's got this same tendency where it turns up here right at 4 watts. And at 4.5 watts, we're back at close to 2% distortion, and we're probably in the range where it's starting to clip right in here. So it is making a little less power. Having said that, it is a 3.5K transformer, just like the Edcore, and the Heyboer is a 3.2K. So it doesn't shock me that having a little lower impedance, that the Heyboer would make a little more power and have a little more distortion. So that all makes sense. So with these 3.5K transformers, we're right at 4 watts, which is fine. We're going to still be testing it at this 0.85 volt RMS range, which is like 4.2 watts. So we come over here to the frequency response, and pleasant surprise, it has much better low frequency response than the Edcore. Well worth the $25 extra to spend on it. And it's honestly, it's about the same shell or in-bell size. It's just got a thicker core than the Edcore, which is probably accounting for the obvious extra pound of weight and this extra low frequency response, while it's staying flat across here, and it's got a little less roll off on the top end too, but pretty much the same. But if you look around here, this is all right at 0 dBs. And then when you get down to 20 hertz, it's down 3/4 of a dB. And let's see if I kind of get close to what the -3 dB roll off. It's right there at 13.5 hertz. So got very similar low frequency response that we saw with the Heyboers for $125. And the Heyboers cost $150, and they are 5 pounds of transformer. So they are substantially bigger, heavier transformers, and we get very similar frequency response with this musical power supply. So let's look at the scope pattern here, and you can see at 1K at this point, let's go to this 0.85 RMS because that's what we were testing these other ones at. And you can see it's got a little ring on the front, which I like seeing, and then it's nice and flat, no gymnastics. We go to the 10K and it still looks pretty good. It's not quite as flat right in here as the Heyboer, but we're not seeing near the gymnastics and wiggle squiggles and stuff we were seeing with those Edcores, which just shows to me it's a higher quality transformer. But here's where this thing really shines. Here's the THD versus frequency. And we're pulling this at 4.5 watts, which is, in this range, like in here where it's starting to struggle. So we're really like forcing it to, be in an unhappy spot. And at 20 hertz, we've only got 9% THD versus the 20 plus. Well, remember, the Edcores wouldn't even run down at 20 hertz. At 25 hertz, the Edcore was at 20% THD, and we've got like 4% THD. So, huge difference on the low frequency of the distortion. And you can see by 100 hertz, it's totally cleaned up. And it holds that same about 1.5% distortion across that whole range. And let's look at the second order harmonic distortion. Let's hope that that still, it drops a little more than I'd like to see. And it does have a little more third order harmonic distortion than I would like. But given that the low frequency is so clean, I think that makes up for the little bit of extra third order harmonic distortion. So for a budget transformer, I would definitely buy the musical power supply over the Edcore. There's no real advantage on this second and third order harmonic distortion. It's got so much better low frequency response and so much lower distortion in these low frequencies. So yeah, this looks like a winner to me for a budget transformer. So next we're going to wire up the Hashimoto EI core and see how this thing performs. Well, it looks like we have to split this up into a few segments, at least 2, probably 3. And so in this episode, we got the Heyboer 3.2K 20 watt tested. We got this new musical power supply 20 watt 3.5K, their HF series. And we're going to be using these in our basic 300B amp, and they tested quite well. And then finally we tested that little Edcore 15 watt 3.5K, which is, it's a decent performer. It's the lowest price one in the group. They're not bad, but I think it's worth spending the extra money and hitting up Matt at Musical Power Supply or Heyboer and getting these big units here that definitely have a nice sound. I personally haven't listened to these Musical Power Supply ones yet. I'm working on a 300B amp, but they tested well, and I anticipate them to sound nice because their little 15 watters are really nice sounding transformers, and to my ears they sound a lot clearer, and they have just more punch than the Edcores do. So, and that was on the 5K ones. So anyway, next we're going to be testing this Edcore Hashimoto, these H203S, these little potted guys, and then we're going to be testing the Tango FC12Ss, and then probably the final episode we're going to be testing these two big 30 waters. We got some Tangos, and we've got these Thermionic Labs guys that we potted, and they're a little higher impedance, so probably going to make less power. Yeah, that might be kind of a not fair comparison, but hey, we're going to check that out too and see what we can learn there. So anyway, if you're enjoying this content, please subscribe to the channel. Please like the video. Thanks to all you folks that are Patreon supporters and otherwise support the channel. I'm always surprised how many folks appreciate my work and just drop me a donation at my website. That's super appreciated. And anyway, until the next video, have a nice day.